Hello, welcome to this e-learning module. Sound control. To exit the module. Transcript. Click once to show the transcript.
ऊपर में बोलो कि आप इसका नंबर दे दीजिए तो जो बाइक में आने के लिए थोड़ा नंबर आई है इसका तो इन लोग का नहीं जाएगा हाँ करेंगे इन लोग लेकर हाँ लोग बोलते थे बाइक को हटवा दीजिए बाइक निकालना है आप है ना आप तो जाने है ना तीस है कल 31 है 31 है अरे कल 31 होगा यार अबे मोबाइल है देख
Hello, I am Shriya. I welcome you to the training program on Industrial Water System. This program will describe the water resource, sources of water, water supply, water cycle, impurities in water, types of water used in manufacturing steel industry and different types of water systems. This module will give you a solid foundation for the upcoming modules on industrial water system. This module will enable you to give a briefing about water resource, sources of water, study about the water supply, describe the water cycle, explain about main impurities in water, describe the types of water in steel manufacturing industry, get an overview of water used in steel manufacturing industry, explain the types of water systems, service water system, industrial water system, and clarified water system. start by a brief introduction on water. Water is an essential for life on earth. In fact, around 2/3 of the human body is made up of water. This is how important it is for us. We use water to drink, to wash, and to cook with. Without sources of water near to us, we would really struggle. Water in the purest form is seen in the form of rain and snow. The source of pure water is water vapor in the atmosphere. It is also produced by melting of ice. This water on reaching the ground absorbs different types of gases from atmosphere like nitrogen, oxygen, and to a lesser extent carbon dioxide. Other gases like ammonia, oxides of nitrogen and sulfur etc. also dissolves during rain depending upon the pollution level of the atmosphere. Apart from this, the surface water travels to various places and catches organic matter, suspended solids, etc. Did you know? A jellyfish and a cucumber are each 95% water. We all know the sources of water. Let us brush up once. Rivers, lakes, and reservoirs form the surface drainage water. Rivers is a source of fresh water. Collecting water from rivers is still a widespread practice. Underground water, which includes shallow well, deep well, and springs. Water from wells tend to be very fresh and clean, and they have been a source of water for many centuries. Except in the very harshest and driest deserts. Rainwater in rural areas is usually safe to drink, though in the cities, rainwater can be contaminated by the pollutants found in vehicles and factory fumes, rendering it highly acidic. Seawater. Our oceans and seas are combined very much the largest water source on earth. Snow melting. Freshly melted snow is generally considered to be safe to drink without further treatment. However, it should not be assumed that because water is frozen that it is safe to drink.
Hello? 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 सेवन मीटर रहता है 7 मीटर दिए हैं अच्छा इसमें सीलिंग 6 मीटर हो गया दे देते चेंज कर देते अरे 6.0 मतलब याद था ना 6.0 का 2 रोल दिए ध्यान में था तो इसलिए ये हो गया दिया सबमिट दिखाएगा वाला को कुछ बोलता है राजी डॉक्टर लोग को ये कोरोना वॉरियर तो कोरोना वॉरियर तो बाइक वाला बन गया मतलब देखो ना कल अच्छा दिख रहा है बाकी सब है क्या
Let us see the water distribution through a pie chart. Around 95 to 96% of total water on Earth is seawater. Around 2% is frozen water. The available fresh water is only around 2 to 3%. Thus, we can conclude by saying that fresh water available is scarce and we are bent upon polluting this precious resource. It is imperative to take proper care to conserve and reuse water. Water in nature follows a cycle. Let us now understand water cycle. Sun, which drives the water cycle, heats the water in rivers, lakes, ocean, and other water bodies. Water evaporates as water vapor into the air. This process is called evaporation. Water released by plants through the process of transpiration and water from soil also gets evaporated. The water vapor gets transported to higher altitudes. As temperature drops, water vapor gets converted to tiny water droplets. This process is called condensation. The water droplets, being heavier than air, fall as rain. This process is called precipitation. Rainwater reaches back to the ground and other water bodies through percolation and surface runoff. And then the cycle goes on and on. Industries use water in large quantities. Many times we hear about the necessity of water treatment when it comes to handling industrial water. Steel manufacturing industry too is heavily dependent on water. Do you know what are the types of water used in steel manufacturing industry? They are as follows: service water, clarified water, cooling water, direct cooling water, indirect cooling water, DM water, soft water, and drinking water. Tata Steel at Jamshedpur has a location advantage when it comes to availability of water. There are water bodies around which are an abundant source of water. The location of Tata Steel at Jamshedpur was chosen between Kharkai and Suvarnalekha rivers due to availability of water. In early days, having taken water from 2 rivers for cooling need of Tata Steel works, it was drained through 4 nalas: Garam Nala, Ram Mandir Nala, Rang Karkhana Nala, and Sunsungaria Nala. Service water system. Moving on to water systems, let us begin by knowing about service water system. First concept of water conservation came in the form of service water system. It is an open circuit comprising of upper cooling pond, pump house number 1 and pump house number 2, blast furnace, steel melting shop, mills and power plant cooling systems, lower cooling pond and dam pump house. Water from this circuit is called service water. In a typical service water system circuit, the water flows in the following pattern: upper cooling pond, pump house number 1 and 2, cooling system of departments, gravity flow through drains, lower cooling pond, dam pump house, make up water addition and cleaning. Service water system. Moving on to water systems, let us begin by knowing about service water system. First concept of water conservation came in the form of service water system. It is an open circuit comprising of upper cooling pond, pump house number 1 and pump house number 2, blast furnace, steel melting shop, mills and power plant cooling systems, lower cooling pond and dam pump house. Water from this circuit is called service water. For an industrial water system circuit, the flow of water can be summarized in the form of the following flow charts. Cold well, cold well pumps, mill roll cooling, return water flow, scale pit at MLSM/RM number 2, clarifier, hot well pumps, cooling tower, make up water, overhead tank. Cold well pumps, motor house air house, furnace skid cooling, cooling tower basin, make up water. Now that we have learned about service water system, open cooling circuit had larger water losses. It also did not facilitate proper cooling and cleaning of water. Therefore, service water was too unclean to be used through water tube of blast furnaces and reheating of furnaces of rolling mills. Hence, there was a need of industrial water system. Industrial water system consisted of two industrial cooling plants. ICP-1 and ICP-2 came in 3 million ton expansion plan. ICP-1 served rolling mill 2 and MLSM, whereas ICP-2 served F-blast furnace. Water from this circuit was called industrial cooling water. ICP-1 consisted of two circuits, one open circuit for roll cooling and other closed circuit for motor house cooling system. Motor house system, apart from air washer system, was also used for furnace skid cooling. Due to exposure to mill stand grease, water in open system wasn't that clean. The system did not use pressure filters for cleaning of water. Water in closed loop motor house system was, however, clean. Let's now study one of the important topic water treatments, which is clarified water treatment. When G-blast furnace, LD2 and slab caster and HSN came, individual recirculating systems were introduced in these three departments. They consisted of recirculating pump houses, that is RCPH, with settling tanks and pressure filters. they evolved into the model of clarified water system we see today. Concept of direct cooling water, that is DCW, and internal cooling water, that is ICW system were utilized. DCW was open circuit, whereas ICW was closed circuit. DCW water, owing to contact with rolling stand grease, were put to rigorous cleaning process. This included settling tanks and clarifier. Both circuits used separate pressure filters, cooling towers and pumps. ICW circuit also had offline filtration of cold well water. The makeup water used by these departments' cooling system is pre-clarified, a river pump house, and therefore called clarified water. Did you know? Unsafe water kills 200 children every hour. Let us start by a brief introduction on water. In this picture, we can see an overview of water treatment process. The raw water is delivered to the headwork of the water treatment plant. The 5 major unit water treatment processes start the treatment to make the water clean and clear. The 5 major unit processes include chemical coagulation, flocculation, sedimentation, filtration, and disinfection. Let's note down the different processes involved in unit water treatment process. Screening, coagulation and flocculation, sedimentation, filtration, softening, ion exchange, reverse osmosis, deaeration for corrosion inhibition, and disinfection. Let's start with screening, which is the first process in water treatment. So, its main purpose is to protect the structure downstream against large objects which might create obstructions, easily separate and remove large matter carried along by the raw water which might negatively affect the efficiency of later treatment procedures or make their implementation more difficult. The usual screen spacing is, for surface water upstream the strainer, it is between 20 and 40 mm. For raw water, from 15 to 30 mm, and for sludge, if necessary, 10 mm or less. For some industrial effluents, especially agri-food effluents, fine bar screening. Here is the layout of bar screens. A bar screen is a mechanical filter used to remove larger objects such as rags and plastics from wastewater. It is part of the primary filtration flow and typically is the first or preliminary level of filtration being installed at the influent to a wastewater treatment plant. They typically consist of a series of vertical steel bars spaced between 1 and 3 inches apart. After the water comes out of the bar screens, it undergoes another process called coagulation and flocculation, which are used to separate the suspended solid portion from the water. The small particles are stabilized by the action-repulsive force that results from the negative surface charge present on the particles. Coagulants with opposite charges of the suspended solids are added to the water to neutralize the negative charges on dispersed non-settlable solids such as clay and color-producing organic substances. Once the charge is neutralized, the small suspended particles are capable of sticking together. The slightly larger particles formed through this process are called microflocs. A high energy is required to properly disperse the coagulant, and particle collisions is needed to achieve good coagulation. Proper contact time in the rapid mix chamber is typically 1 to 3 minutes. Inorganic coagulants such as aluminium and iron salts are most commonly used. When added to the water, they furnish highly charged ions to neutralize the suspended particles. The inorganic hydroxides formed produce short polymer chains which enhance microfloc formation. Common coagulant chemicals used are alum, ferric sulfate, ferric chloride, ferrous sulfate, and sodium aluminate. The first four will lower the alkalinity and pH of the solution, while the sodium aluminate will add alkalinity and raise the pH. Polymers are becoming more widely used, especially as coagulant aids together with the regular inorganic coagulants. And ionic polymers are often used with metal coagulants, and cationic polymers may be used alone or in combination with the aluminium. When we see flocculation over coagulation, flocculation is a gentle mixing stage that increases the particle size from submicroscopic microfloc to visible suspended particles. These microflocs are brought into contact with each other through the process of slow mixing. Collisions of the microfloc particles cause them to produce larger visible flocks called pin flocks. The flock size continues to build through additional collisions and interaction with inorganic polymers formed, and then microflocs are formed. Once the flock has reached its optimum size and strength, the water is ready for the sedimentation process. We all know that sedimentation is the process of settling or being deposited as sediment, but all that is not enough. To know more, let's meet Mr. Ashok, who will be telling us about sedimentation in more detail.
Sedimentation is a treatment process in which the velocity of the water is lowered below the suspension velocity and the suspended particles settle out of the water due to gravity. The process is also known as settling or clarification. Most water treatment plants include sedimentation in their treatment processes. However, sedimentation may not be necessary in low turbidity water. In that case, coagulation and flocculation are used to produce pinpoint, very small floc, which is removed from the water in the filters. The most common form of sedimentation follows coagulation and flocculation. This type of sedimentation requires chemical addition in the coagulation or flocculation step and removes the resulting floc from the water. Sedimentation at this stage in the treatment process should remove 90% of the suspended particles from the water, including bacteria. The purpose of sedimentation here is to decrease the concentration of suspended particles in the water, reducing the load on the filters. Sedimentation can also occur as part of the pre-treatment process, which is known as pre-sedimentation. Without coagulation or flocculation, plain sedimentation can remove only coarse suspended matter, which will settle rapidly out of the water without the addition of chemicals. Pre-sedimentation can also be called plain sedimentation because the process depends merely on gravity and includes no coagulation and flocculation. This type of sedimentation typically takes place in a reservoir, grit basin, debris dam, or sand trap at the beginning of the treatment process. While sedimentation following coagulation or flocculation is meant to remove most of the suspended particles in the water before the water reaches the filters, pre-sedimentation removes most of the sediment in the water during the pre-treatment stage. In addition, pre-sedimentation basins are useful because raw water entering the plant from a reservoir is usually more uniform in quality than water entering the plant without such a holding basin. Clarifier or settling tank is used to carry out the sedimentation process. Let us see what are types of basins. There are basically three types of basins: rectangular basins, double-deck rectangular basins, square or circular basins. Rectangular basins are the simplest design, allowing water to flow horizontally through a long tank. This type of basin is usually found in large-scale water treatment plants. Rectangular basins have a variety of advantages: predictability, cost-effectiveness, and low maintenance. In addition, rectangular basins are the least likely to short circuit, especially if the length is at least twice the width. A disadvantage of rectangular basin is the large amount of land area required. Double-deck rectangular basins are essentially two rectangular sedimentation basins stacked one atop the other. This type of basin conserves land area, but has higher operation and maintenance cost than one-level rectangular basin. Square or circular sedimentation basins with horizontal flow are often known as clarifiers. This type of basin is likely to have short-circuiting problems.
Thank you, Mr. Ashok, for the valuable information. The water after sedimentation is carried out into the clarifier. Clarifiers are nothing but settling tanks built with mechanical means for continuous removal of solids being deposited by sedimentation. Circular clarifier with surface skimmer visible in the lower right. As the skimmer slowly rotates around the clarifier, skimmed floating material is pushed into the trap visible above the fenced enclosure at the lower left.
थोड़ा सा नहीं ज़्यादा
The most commonly used settling tank is rectangular sedimentation tanks, which has effluent weir structure visible above the fluid surface. These rectangular sedimentation tanks are called settling tanks. As soon as the water leaves rectangular tanks, it is undergone water filtration, which is the process of removing suspended solids and contaminates from water in a granule media filter. The filter media is contained in a pressure vessel of steel. The filter bed is typically 1 to 1.5 meter deep. The filter vessel usually has about 30% freeboard to allow for expansion of the filter bed during backwashing. We know that filtration removes contaminants, but there is much more behind this, which is filter operation. The filter medium used is sand, but other materials like anthracite, garnet, manganese dioxide, granular activated carbon, dolomite and others are used for special applications. Water enters the top of the vessels and flows downwards through the bed of media and leaves through a collector system at the bottom. Contaminants are removed through straining or adsorption depending on the chosen media. Water is passed through the filter until either the head loss across it rises to preset value. It is then taken out of service and cleaned by backwashing with clean water. The backwash water enters the bottom of the filter vessel and flows upwards through the media bed, which starts to fluidize that are the media grains begin to separate from each other and to float freely. The fluidization of the media releases the retained contaminants, a process which may be assisted by doubling air through the bed, which causes the sand grains to rub against each other, dislodging the retained contaminants from the surface. The contaminants are then washed from the bed and out of the filter to waste. Did you know? Water expands by 9% when it freezes. The important part of water filtration is the pressure filter, which plays a major role in water treatment. Granular activated carbon is widely used to remove chlorine from main water supplies prior to treatment by ion exchange or reverse osmosis, since it could cause damage to the resins or membranes. Dechlorination by activated carbon filtration also removes the taste associated with chlorine. Activated carbon filtration is also used to remove a wide range of organic chemicals, including chlorinated hydrocarbons, pesticides, and the species that cause taste, odor, and color. Manganese dioxide is used as a catalytic filter bed to remove iron and manganese from borehole water for a range of industrial applications. Similarly, dolomite or limestone chips are occasionally used in filters, either alone or as a separate layer above sand to neutralize low pH waters. The media slowly dissolves and has to be replaced at regular intervals. Because filtration is a batch process, filters are usually built in batteries consisting of 2 or more filters so that filtration to service can continue while one filter is being backwashed. Now that you have completed the module, it's time for you to check your knowledge by answering these questions.